Neil deGrasse Tyson passionately shares that the most frustrating and saddening discovery made by Voyager in the past decade is a finding that scientists weren't ready for. The probe sent back troubling information from space, leaving experts restless and everyone in a tense mood. Scientists and analysts have been stepping away from their usual tasks to investigate these mysterious objects that Voyager just detected. We don't know where these strange things come from or where they're headed. However, we can be certain that we've never seen anything like them before. What are these puzzling items found by Pioneer 1? Join us as we explore these reactions in Neil deGrasse Tyson's Pioneer 1, which has identified 500 dark objects moving through space. For nearly 50 years, Voyager 1 has been traveling through space, exploring areas that Earth-based telescopes can't reach, and revealing astonishing discoveries that leave us speechless. Voyager 1 has become the heart of new regions in interstellar space. This engineering marvel has opened our eyes to the wonders of the universe. Recently, Neil deGrasse Tyson confirmed that Pioneer has detected 500 dark objects floating silently in space. This news shocked many scientists, sparking a frenzy as everyone began analyzing the data collected by Pioneer 1. Something unusual was happening, and experts struggled to understand this surprising finding. Various theories began circulating as scientists tried to piece together the mystery. If another rocket had sent back this puzzling data, researchers might have questioned its accuracy. But we are talking about Pioneer 1, a space probe that has been exploring the vastness of space for almost 50 years and has exceeded our expectations. Much like a patient who has overcome an illness, Voyager 1 has surpassed the scientists' initial expectation of a 3-year mission, spending over 45 years in space and making groundbreaking discoveries. The most fascinating aspect of the story is that Pioneer is sharing this incredible journey from billions of miles away. The last time researchers checked, Voyager was 14.5 billion miles from Earth, continuing its journey through space without any sign of slowing down. Researchers report that the space probe travels at a speed that covers the distance between the Earth and the Sun many times each year. This fact has been hard for scientists to accept, considering that one would expect the probe's speed to have significantly decreased after so many years. However, it seems that Voyager 1 is an exception, and its recent discoveries support this. It seemed like an ordinary day for scientists when Voyager 1 sent exciting news that would be remembered for a long time. The probe accidentally discovered some unusual objects passing through space. This revelation was shocking, explaining the initial confusion among cosmologists when they found data showing around 500 dark objects appearing from nowhere. In an instant, we went from having no information about these objects to experts scrambling to find answers to this puzzle presented by nature. Scientists were in a dilemma, and the blame could only be placed on one party, Pioneer 1. Suddenly, researchers knew that finding the answers lay heavily on the shoulders of the space probe. At first, when news of this discovery broke, some scientists speculated that it could be a mistake. They thought Voyager might have mistakenly detected these objects and sent back incorrect data. If we follow this line of thought, it seems like a plausible explanation, especially since Voyager 1 was launched back in 1977. Almost 50 years of active service for humanity, one might expect that the probe's computers would have worn out and begun to malfunction, sending back low-quality information to the ground team. As interesting as this theory is, scientists have cautioned against jumping to conclusions, as it would undermine the probe's achievements. Despite the harsh and unpredictable environment of space, Voyager 1 has consistently sent back valuable data about our universe. Defying the skeptics, the probe has lasted so long due to its dual redundant computer systems. Like its twin, Voyager 2, Voyager 1 was equipped with 2 sets of command systems, data processing systems, and control systems. This redundancy has been the secret behind the probe's enduring spirit in exploring space and making discoveries. This built-in redundancy allowed for continuous switching between systems and the ability to activate and use computer parts, prolonging their lifespan. When designing Voyager 1, engineers on Earth developed plans to maximize the efficiency of the spacecraft. This meant that the probe's instruments had to be built using simplified systems to meet time constraints and power limitations. Electrical engineers concluded that the instruments should use straightforward systems based on hardware logic. As a result, Voyager's computer systems incorporate power management, 6 onboard computers organized as a distributed system with 3 dual redundant pairs. Having overcome this challenge, scientists faced the next big task: keeping the systems running. They tackled this issue by creating a power management plan. Here's where it gets interesting. Power management involved supporting the functioning components of Voyager's computer systems. This was a challenging task, given the limited power resources on board the spacecraft. However, experts devised a strategy to monitor and optimize power usage. One real instance of these energy management strategies is the scheduled shutdown of non-essential systems. Researchers faced a difficult choice and employed a meticulous approach to identify and deactivate components or subsystems that were not vital for the probe's primary mission objectives. This is evident when examining the radiators linked to certain instruments that had to be turned off. These radiators were originally intended to maintain the instruments at specific temperatures for optimal function. However, the strategy was adjusted to activate them only when necessary, to significantly lower energy consumption on the spacecraft. This reduction in energy use creates a ripple effect. It prolongs the probe's operational life. It's a mutually beneficial scenario. It's crucial to highlight that the decision to power down non-essential systems wasn't made lightly. Such a move demands careful assessment of the trade-offs between conserving energy and fulfilling the spacecraft's scientific aims. Each decision required the entire team to collaborate in evaluating the impact of shutting down particular systems on the quality and availability of scientific data. Emotions were set aside. It was solely about the facts at hand. The team sought to optimize energy efficiency while ensuring the spacecraft could continue collecting vital data about our universe. Both engineers and scientists insisted that nothing should hinder Voyager 1 from uncovering the profound secrets concealed in the far reaches of space. Secrets that the universe has guarded for years. Additionally, power reduction isn't the only strategy NASA specialists are employing to keep Voyager functioning in space. They also had another significant advantage to support the probe. The team devised energy management plans that adjusted to the constantly changing conditions of the probe's environment. For instance, as Voyager 1 travels further from the Sun, the available solar energy diminishes. This presents a challenge, but the experts were prepared. They compensated for this declining energy by ensuring the spacecraft adjusted its energy consumption accordingly. This adaptable approach is advantageous for NASA engineers and scientists, as it guarantees that the available energy resources are effectively allocated to support the probe's essential tasks and data transmission back to Earth. The good news doesn't end there. Ongoing technical enhancements and updates in energy management have allowed engineers to refine the spacecraft's power system over the years. A closer examination of these upgrades reveals that they include more efficient energy distribution, improved battery charging techniques, and advancements in energy regulation and control. The careful planning and management of energy resources have empowered Voyager 1 and its sibling Voyager 2 to continue exploring the universe. The announcement sent waves through the scientific community. Neil deGrasse Tyson's announcement resonated globally, highlighting a decade of detailed investigation by Voyager 1 in the vastness of interstellar space. The probe had unexpectedly uncovered an anomaly: 500 mysterious objects, their origins and purposes concealed in deep secrecy, moving silently through the void. This startling discovery ignited a wave of scientific inquiry. Researchers and scientists worldwide began collaborating to understand these strange objects, striving to uncover their origins and purposes. The significant finding by Voyager 1 opened a new chapter in space exploration, challenging existing theories and inspiring fresh ideas about cosmic enigmas. The ongoing analysis of this data promises to broaden our understanding, potentially revealing new insights into the nature of the universe and our place within it. As we continue to investigate the mystery, the ultimate goal remains to uncover the truth behind these dark objects and their implications for our comprehension of space. As researchers delve deeper into the 500 dark objects identified by Voyager 1, the scope of exploration has expanded. The initial data collected by the probe has already sparked several intriguing theories. One hypothesis suggests these objects could be remnants of ancient astronomical events, such as debris from exploded stars or fragmented asteroids. Alternatively, they might consist of materials unknown to current science, hinting at new forms of matter or entirely new physical phenomena. Astrophysicists are employing advanced computer models to replicate the trajectories and possible origins of these objects. By analyzing their movements and speeds, researchers hope to determine if they originate from a common source or if they emerged from various distinct events. This aspect of the study is crucial for understanding the broader implications of the discovery, such as the potential existence of previously unnoticed cosmic cycles or interactions. Observatories around the world have joined efforts to track these objects. Ground-based telescopes are being utilized to verify and augment the information returned by Voyager 1, providing a more comprehensive view of their properties. High-resolution imaging and spectral analysis are key components of this work, aiming to identify any chemical signatures or physical characteristics that could reveal more about their nature. In addition to observational initiatives, theoretical physicists are exploring the potential effects of these discoveries on our understanding of fundamental physics. If the objects exhibit unusual gravitational effects or electromagnetic properties, they could offer insights into theories of dark matter or dark energy. Such findings could reshape our understanding of the universe's most mysterious aspects. The discovery has also ignited collaboration across various fields. Cosmologists, mathematicians, and even material science experts are contributing their knowledge to solve the enigma posed by these unknown objects. This teamwork fosters a more comprehensive understanding of the data and ensures that all potential angles are explored. In response to public interest and scientific enthusiasm, NASA has begun releasing periodic updates and findings related to the ongoing investigation. These reports aim to maintain transparency and stimulate educational initiatives that engage students and enthusiasts in the scientific process. Looking ahead, Voyager 1's journey and the mystery of the 500 dark objects will likely remain a central focus in astrophysics. With continued observation, theoretical analysis, and global collaboration, scientists hope to solve one of space's most intriguing mysteries.